Question number 1. A spherically symmetric charge distribution is considered with charge density varying as something. You need to find out the electric field at point P. So, as the electric field at point P, as this P is within the circle, this P is within the circle. So, the condition given as rho is variable, and for r greater than r, rho is 0. So, you need to apply Gauss law. E dot A equal to Q by epsilon naught. This Q you may write that rho dV. A into area is 4 pi r square. Area is 4 pi r square, and for rho you will write rho naught as you are finding within r less than r. So you need to write rho 3 by 4r minus r by r. dV is 4 pi r square dr by epsilon naught. So E equal to 4 pi get cancel out the constant term. Rho naught by epsilon naught 3 by 4. Let this is r minus 1 by r. R into 3 by 4, and there is r square. So r square will be what? R cube by 3. So you will clearly write that r cube by 4 minus r into r square. R into r square will be r cube. So that will be r to the power 4 by 4. If you solve this one, E into r square is this one, and E is equal to rho naught r by 4 epsilon 1 minus r by r. Now moving on to another question of electrostatic. This one is also a good conceptual question. Question number 6. So in this question there is a solid metal sphere of radius r. So this is a solid metal sphere of radius r, and this is A. This is B. So for this solid sphere, now we need to find out electric field E versus R, and it is given that in this portion there is a dielectric. This portion there is a dielectric. So for this one you need to find out E as a function of distance smaller from center O. So as R is less than R, at that place E should be 0, because that is within the conducting metal sphere. So whenever you will be going from this, will be in this zone, there you will be getting electric field. For how much value? A equal to kq by r square. So E will be proportional to 1 by r square. Now see, this sphere is having charge q. So this sphere is having charge q. So you may write q over here. This will induce a charge minus q, and plus q will induce in this side. So if you draw a Gaussian surface at this position, what will happen? That in this Gaussian surface, or better if you draw this inner side of the outer sphere as a Gaussian surface, so within this the net charge is 0, so electric field will become 0. Electric field will become 0. But whenever you will be moving from this to this point, there also electric field will be 0, because within this any Gaussian surface the net charge is q minus q 0. But when you move to the outer portion, then again net charge become q. So again E is equal to kq by r square. This will be applied, smaller square. So, and from there onward you will be getting electric field. So which option will be correct? So initially there will be no electric field. From A you will be getting electric field up to B. From R you will be getting electric field up to A. Then from A, as I said, from A to be in this zone, if you draw any Gaussian surface, the net field will be 0. So from A to B, the net field will be 0. And then from B, again this will be inversely proportional to 1 by r. So this is it. This should be the solution. Now moving on to the another question.